Hello everyone, this is wattsup, and this is Half Coil Syndrome 3. I wanted to start expanding on the alternative ways of coiling and whatnot to counter Half Coil Syndrome. But I just decided to make the number 3 an expansion of the Half Coil Syndrome 2. Just wanted to show you guys a few things that we'll also touch on what I'll be getting into a little later on, which is the main construct, which is a new construct called spin conveyance. And spin conveyance will basically do away with theories involving magnetic fields and electrons. Just showing that a magnetic field and electrons are not required in any construct for our effects to work as they do. And so some of you might find this totally radical. Some of you might find this refreshing, and it'll give you hopefully a new perspective on the way to look at the toys that we play with when we're looking for means to obtain overunity or free energy devices. Okay, so basically what we have here, we have a coil here, the same coil as before, and I showed you here that when I put a pulse across this coil, and I'll bring this up to about frequency doesn't really matter as long as it's high enough to make a nice effect. Doesn't really matter the frequency itself. So here we go. You see it's totally off the chart here. I'll bring it down. So here you have an effect here, and as we're going down, you're going to see that this thing is going down to flatline almost here at the end. And this is just reading the amount of energy that's available at this particular sector across this core. Okay? And it's really flatlined right here. Now, when I remove one of these terminals, what happens inside this coil? And this is where spin conveyance comes into play. So let me just take out I'll take off the negative here, and I'll show you what's going across here. I'm just going to bring this up just one little tad here on the scope. And here you can see basically not much happening. Let me get this thing here away from there. So you see here, now for our purposes, I'll be using the word positive and negative, and to determine, you know, positive and negative, because that's the way we were brought up. In Half Coil Syndrome 2, I mentioned that there's a possibility where the field here, the active part of the field, is the only real polarity. There's no two polarities. There's really one polarity, but that has two perspectives. So, I mean, if you look at a pole, look at any pole. A pole is a polarity. A pole has two ends on it. Okay? Now, and the directionality, if you want, is different on each side, but it's the same spinning direction, or it's the same direction, but you get two sides when you're looking at it from each end. But we're going to call this positive, we're going to call this negative for now to simplify matters. So I have my negative here, and I see here, okay, nothing much. And here I'll take off that negative and I'll put the positive here. Okay, we'll see here, look at that. All across the coil, this whole coil, right down to the end here, right down to the end of the wire, is now all positive. So what happened? And then let me take this off. No coil, no nothing. And it's just the ambient whatever that could affect this. It could be the Schumann resonance. It could be my lights in the office, whatever. But here we go. So here I have a positive. the positive just went all across this coil, right to the end. Okay? Now, I'll put the negative on. The negative came in from this end, and it's going towards the middle, and it's meeting the positive coming in from here. And since the positive starts on this end, this is a lot higher, and the positive is a lot lower here, because this is now the negative end coming in here like this. So basically both of these are coming in to the coil. Now in regular electronics, we're taught that the circuit flows in a certain direction. You know, it's going this way or it's going this way. You know, some people say it's negative to positive, some people say it's positive to negative. But if that was true, if at the speed of known, you know, the published speed of electricity is, geez, I can't remember it offhand, 280,000 something, extremely fast. If that's the speed of electricity, then how can it have time to slow down here and reduce? This is so fast. What they're saying is so fast that it should have passed this coil in the millionth of the second that I did the connection. But no, it's not. When both sides are connected, we're getting a decrease. Now, how can that decrease happen? If there's a flow, if you're on a train, on a 100-wagon train, can one of those wagons go faster than the other? No. All of them are going the same speed. If the last train is going at speed X, all the trains are going at speed X. You wouldn't see a slowdown anywhere. So how can this happen here in this coil? It's a major inconsistency, and this is one of the points where the construct that we see now with you know, you see all these animations of the coil being connected, and then you see these dotted lines flowing through in a certain pattern like this. That can't be. That's impossible. It just cannot happen like that. And this simple little test and logic, why would it go down? If it's going that fast, it should be out of this at the speed that it was here. It should be at the speed it's here right away. There's no damping possible. Okay, so this is to show you guys that something is wrong in the present construct, and I'm trying to work it out. I'm trying to get the words and trying to get the system or a way to show what this is. Spin conveyance is the only logical answer that I could find that is constant and that is explaining all these effects that we see that are left with so many question marks. You know, even we use the word field and electron 100 times a day. We don't even know what it means. The best EEers around don't even know what a field really means. And we've never seen it. We know that we have an atom. The atom is real. And we're too lazy to say the atom is doing all this work. So we invent a field, which is intangible, can't touch it, can't see it. We invent an electron, another intangible, can't touch it, can't see it. And we're putting all of this onus on all our effects on the field that's never been proven, and an electron that's never been proven. So we've got a problem here. We've got a problem, and I think that in the overunity research, which is looking for free energy, which is really out of the box, which is really out of the general acceptance of standard EE, we've got to go out of the box. We've got to get these reasons. We've got to find the logic of why we don't have free energy today. And the only major reason is our construct is failing us. The present construct is failing us. It's giving us zip all for answers, and it's leaving us cut and dry. And we're working with transformers that are checkmate from the beginning. So, okay, so what I'm going to do now is I'm going to try something that I haven't rehearsed or anything, hopefully. If not, I'll cut the video here and then start it later, but I'm going to try and do this in one shot. I'm going to put a scope, only the positive of my scope, on the negative, and I'm going to put the scope, only the positive of my scope channel A, on the positive. Okay. Actually, I want to put this on the wire itself because I'm going to be disconnecting. I'm going to be disconnecting this. Okay. So, let's bring this down to somewhere where you can see something. Bring this voltage down. Okay, here, this is our negative, this is our positive. Okay, right now this is at 5, this is at 5, both are at 5 volts. Divider, and so you see here I have a wave here, and I have my negative side here. So I got a negative wave and I've got a positive wave. So let's just see on the B channel, we just lost it. Can we catch it? No. It's like, so let's put this back. Okay. So what I want to see here is, what is the reaction of this when I remove the positive here? Or actually, when I remove the negative. If I remove the negative, look what happens. Now I'm totally off. I'm going to have to put this at 10x. I'll put this here at 10x. Put this back on here. Okay, and we'll bring this up a little. There, and there. Okay, so here I have, this is my positive, and this is my negative. So let me take the negative out. Back. Back, back. Now, do you see what's happening here? Let me put this back on 5 here so that you can at least see something. On the B channel. So I'm going to connect the negative, and then I'm going to release it. I'm going to connect the negative, I'm going to release it. I'm going to connect the negative, I'm going to release it. This is just like a make-break pulse. What's happening is we're seeing how flyback is generated. Okay? Flyback, when you're pulsing a coil on the negative side and that negative opens, what happens? Positive rushes back into the coil. It rushes back into the coil and it pushes out the negative that was in there already from where the negative had reached originally when it was connected, let's say from halfway here. Well, the positive is now reclaiming the complete coil. Hence, we see this here. Totally different from the scope of the positive side. So this is what's happening with our coils and flyback. When you're unpulsing, when you're opening the pulse, the positive that is continuously connected on this situation reclaims the coil, and it's that reclaim of the coil that we see as flyback. It's not a collapsing field. fields cannot collapse. Fields are not like dogs that will, you know, run towards you at the whistle, you know, at the dog whistle. I mean, we've got this mental image of a field that's coming out of this coil, and then when we disconnect, it's the collapsing field comes back into the coil, and we see this drop down on the sine wave. That's not what's happening. It can't happen like that. Fields cannot do that. First of all, fields do not exist. In spin conveyance, fields do not exist. So that's why I had a little disclaimer on Half Coil Syndrome 2 when I was using the word field. It was to get it to a level where some of you guys can understand this. So here you see where your flyback's coming from. Now, if I take this, I'll put this on channel A, and I take that, and I'm pulsing the positive side now. Now it's the make break is here. Okay? And when I open the make break, what happens? I'll still get flyback because now it's the negative that's reclaiming all of the coil. So you can have flyback backwards and flyback backwards and flyback forwards. You can get flyback from either side of the coil depending on which side you're pulsing. In all of these, half coil syndrome still exists. The only real way that you can do away with half coil syndrome and create a quasi change or a better change in the complete length of the coil is to pulse both ends. If you open both ends and you close both ends and you open both ends and you close both ends, the coil can't do anything else. It can't be rebiased by the other polarity. It can only just go to neutral. And neutral means when there's no power on this core, all the atoms in this copper coil are biased to the earth, to the Earth's core. Once these are off, the only real core that's the closest to this coil that's worth mentioning is the Earth's core. And then after that, it's the sun. Because of proximity, the sun comes in second, in this case, and the Earth comes in first. So this coil here, when I'm removing everything, it's biased to the Earth. When I put a negative on, it's biased to the negative. If I remove the negative, put a positive, it's biased to the positive. And the name of the game in coupling is to create a shift in polarities. And that shift on a core is seen by a secondary as a real change. It's the virtual equivalent to a rotating magnet. And if we go and see how all of our electricity is produced, there's a rotating magnet somewhere. Whether it's a hydro plant, whether it's a coal-fired plant, you know, with turbines, it all has to do with a changing polarity. So we change a polarity. We've got a magnet. Let's see now, how can I do this? Let's say this was a magnet, or this was okay, let's say this was a motor that's turning. And there's a coil in the middle, and this magnet here is turning. What we're doing is we're generating rotation, spin, inside the atoms of the core, of the copper. That's all we're doing, and that spin is being conveyed from one copper atom to the other, right up to the end of the wires. And when we get to the end of the wires, they're just two ends of the same spin. It's as if this thing here becomes a conveyor belt or a spinning flexible drill extension. And it's just spinning like this. Now when it's spinning like this, you've got one end here, one end there. One becomes positive, one becomes negative. That's where we get our positive and our negative. It's out of the center spin that we get two ends. And then we get the two ends from my function generator. That's all my function generator is doing. It's producing that here on these two terminals. And I'm transmitting it or conveying it because it's being conveyed across this wire. It's being generated in the frequency generator, conveyed across this wire, then conveyed into this coil, and it's shorting in the middle here. And that's what we call the basis, the basic idea of spin conveyance. It gets a little more complicated than that, but I'll get into that in a few other videos when the time is right. And I had to touch on it a little bit if I wanted to continue on with the half coil syndrome. Let me see, is there anything else? Here's a little fun little thing that I found the other day. Take this off. Now, can I close this up? We won't be needing that. I'm just gonna put some compasses here. Here, I'm going to put a compass here and a compass here. I'm going to bring this down to let's say 2 hertz. So here we see I'm pulsing this at 2 hertz, and if you can see this well enough, let me see if I can get this in there a little more. You can see this well enough at 2 hertz. Compasses are not moving. So let me put one here. Let me put one here. Let me push this a little more further aside. So we have two now that are moving, and these ones here are just wobbling enough. So let's put some more. Let me put this one here, and let me put this one here. This is spin conveyance. This is basically what spin conveyance is. It's the nuclei of the copper atom that is a gyroscope. It's basically a gyroscope, and that gyroscope is unbalanced because in the elemental table, copper does not have the same amount of neutrons as protons. So there's an imbalance, and it's that imbalance. When there's no potential on that copper, like electricity, the imbalance falls towards the Earth. And they're all biased towards the Earth core, because besides whatever we do on our benches, the next biggest coil around is like 3,000 kilometers right under our feet. It's a huge, huge, huge force. It just so happens that we're far away from it enough that we don't really feel the intensity, but copper does. Any kind of conductive material, actually any kind of atom, will feel it to a certain degree, except to a lesser degree when the neutrons and protons are the same count, or the difference is very, very little, like one. Like aluminum, the difference between neutrons and protons is very small, whereas copper, the difference between neutrons and protons is a lot more. So copper has the ability to convey just like the aluminum does, but aluminum is okay, we'll get into that when I get into spin conveyance. I don't want to get into that now. So half coil syndrome, we see here that this negative side is reacting also, but we have to realize that it's not because there's a low pulse here on this side, it's because of the core on the pulsed side that's extending outward and creating this. And here's a fun thing that I saw the other day. I think I had this at 7.84. I'm going to try and get 7.84. hertz. We all know what 7.84 hertz is. That's 7.84 hertz. And look at this. This, I have trouble trying to explain this. 7.84, 7.85, 7.83 were in the Schumann resonance, which is the pulse frequency of the Earth itself. And what I'm gathering from here is that the magnets, the compasses are turning too fast to convey physically, because this is a major physical conveyance here. So it can't really do it that fast. But these compasses here are holding a certain orientation, and they're just holding it like that. I'm just thinking that they're probably too far from the main coil here, so they're being held by the Schumann resonance, since everything is happening at 7.84, which is the same thing as the pulse. But then I'm wondering, well, how can I match the phase? Am I in phase with that pulse, with the Schumann resonance? And that I couldn't tell you at this stage. I just wanted to show you this. So, so I went a little deeper on that. What else? No, we'll leave it at that. And the next video, I'll start putting some coils together in parallel and in series, and showing you different results of working out coiling schemes and stuff like that in the next one. So thank you very much, and have a good day.